Having planning-enabled infra providers are not enough to start planning. In our scenario, actual volumes are provided from COPA, and we want to use those actual volumes to plan into the future. Our model is very simple, containing only a few info objects, but in real life, COPA might contain 50 or more characteristics, and all of those characteristics may need to be filled for planning. However, the user may not always know or care what the right combinations are for planning. All he wants to do is enter his planned volumes as quickly and easily as possible. A volume planner may only look at the sales area, customer, and material for his planned volumes and does not need to see other characteristics such as brand, material group, and material type, and so on. So while the planner does not want to see these fields or have them available for planning, they must be available for reporting. The aggregation levels allows us to meet this goal. The aggregation level is a subset of the characteristics of our infra provider, which is either an ADSO or a composite that we want to plan on. We will adhere to the following principles. We will create the aggregation level on the composite provider. This will give us the greatest flexibility possible. Once we created the aggregation level, we can replace the underlying ADSO with another ADSO, provided that the info objects are similar, without it affecting the aggregation level, and it may only have a minimal impact on our queries, filters, planning functions, and so on. The aggregation level based on the composite also allows us to write to multiple info providers with queries or planning functions. Thus, we can write to multiple ADSOs where the data is partitioned across ADSOs. The characteristics of aggregation level should only be those characteristics of the underlying ADSO, and since the objective is to write data to an ADSO, we should not include any characteristics from an ADSO that we are not writing to. If we include wrong characteristics by mistake, the system will save the aggregation level, but we will get an error when saving the data in the query or planning function. Any characteristic that is not in the aggregation level, but in the underlying ADSO, will contain the value hash, unless we have a characteristic relationship that fills the field. Now let's look at aggregation levels by way of an example. Say we have the following records for actual volumes. We now build our aggregation level on a subset of these fields. The data will be aggregated on the field selected in the aggregation level. We can now use the actuals from above and copy them to version 101. The results in the database will be reflected as follows. The first aggregation level we will create is an aggregation level in preparation of a copy function we will write in the next chapter. Our first planning function will consist of a copy function where actual volumes is copied from actual volume ADSO tvol VWO to the planning ADSO tvol A20. The requirements from the customer states. Initially, volumes must be planned on material level with a top-down distribution to customer based on a reference historic period. The aggregation level should contain all the characteristics of actual volume ADSO, excluding customer as a minimum. Time characteristics 0 fisc year and 0 fisc per 3 are also excluded, as those are automatically derived from 0 fisc per. So let's create our aggregation level. The aggregation level is created in Eclipse, and we simply go to our info area and we can right-click. It's a new aggregation level. Or we can go to the aggregation level folder and say new aggregation level. So the aggregation level we're going to create is TSL P1001, but I've already created it, so I'm just going to create number 9. And the description is going to be volumes planning. And it will be based on our composite provider, which is TSL P10, and finish. So we're now presented with the initial screen or the general screen of aggregation level. So we go to output, and here we select our fields. So I can right click and say show infra provider view, and it'll give me all the fields that's in my infra provider, and from here on I can simply drag and drop. So I can select my sales org, quantity, the unit of measure, material, the fiscal year period, version, value type, and that should be sufficient. So I can drag them into my field and verify the characteristics and the key figures that I'm going to use for planning. So at this stage, the only step that is remaining is to activate. So I can simply click on Activate the object. Where aggregation levels control what fields are written to, the filter tells us which data intersection or target area to write to. A clear distinction must be made between what is reference data and what is my target area. It becomes really important when considering that the data in the target area is always locked whenever the filter is active, either through a query or planning function. We want to lock a small area as possible to enable multiple users to work on the same ADSO or aggregation level without stopping their work. So let's look at an example as an extension of the example used for aggregation levels. In the example, we are copying information from one version to another. Let's assume that it takes place through the use of a planning function, and the purpose of the planning function is only to copy data across versions. However, the user might want to limit the copying of data to a sales organization, for example. Based on these statements, only a single field value actually changes, 0 version, and the sales organization is there only to refine the selection. In this case, the filter will at minimum contain 2 restrictions, 0 version and 0 sales org. The characteristic 0 version will have to be restricted to the target, in this case version 101, while the planning function must still select data from version 100. We can achieve this by creating 2 variables and use them in the filter and planning functions as follows. The target will be in the filter, while the from selection will be in the formula. If we incorrectly try to write to a value outside our filter value, we will be issued with an error and the data will not be saved. It is good practice to add as many variables to the filter as possible in order to lock the least amount of data. So how does the filter interact with queries and planning functions? In both instances, a selection from the target area is performed. The query will only select the data in the target area, while the planning function will select data in the target area as well as potentially selecting data from the reference data. There is no need to add both source and reference data to the filter. If you do this, your function will still work. However, you will incorrectly lock the reference data for planning as well. There are 2 methods to create a filter. One method is with transaction RSPlan and the other is using Eclipse. But let's create the filter using Eclipse. So we've already got our aggregation level TSLP 1001, and we're going to right click and say new filter. And the filter we're going to create is TSLP 1001 FL1, but I've already created it, so I'm going to create 9. And the description will be copy version. And finish. Under the filter tab, we're going to add the filter characteristics by right-clicking and saying add characteristic. Because the filter contains the target characteristics, I'm going to explain the principle using info provider and version. The rest of the characteristics can be restricted as per the manual. To restrict the characteristic, we simply right-click and say restrict. And in our case, we're going to select a variable for target version. For info provider, that will be the target info provider we're going to write to, and that will be tvol A20. Once the characteristic restrictions have been made, we can save the filter.